All right, and welcome to Unit 5, Circular Motion and Gravitation, Lesson number 1, Kinematics of Circular Motion, example number 2. Now, before we jump into this example question, like I mentioned in video number 1 of this series, I am going to be discussing some mechanics of centripetal acceleration. Now, centripetal acceleration has some themes, and we're going to use it fairly similarly to acceleration previously. There's just a couple special rules around centripetal acceleration. Now, we talked about in lesson 1 the velocity of an object spinning around a central point. The velocity is going to be tangent, that was a terrible arrow, tangent to where it is. Well, thing with centripetal acceleration is that since this object is always spinning around the mass, its direction is constantly changing. And there are two ways we can change the value of acceleration. We can change either, how hard we're pushing. We can push harder to make it accelerate more, push less hard, it'll accelerate less quickly, or we can change the direction. Well, when we're moving in centripetal motion, the acceleration, the direction, is constantly changing, right? So our velocity is tangent. Our acceleration is always moving towards the center of a circle. So acceleration towards the center of the circle. But if we move down to here, our velocity is tangent to the circle, but our acceleration moves towards the center of the circle. We can think of this as if our object is always seeking. It's seeking to reach the center of the circle. Right? If it's pulled by a cable, that cable is constantly pulling it inward. We can do one more example. If we say this cable is now over here, and our velocity would be up in this direction, our acceleration is still towards the center of the circle. So at every point, the acceleration is always towards the middle. Okay, I've said that enough times. I think you get it. I have two formulas to go over with you, and then we're going to jump into this fairly straightforward formula manipulation example problem. Okay, the two formulas that we have are AC is equal to V squared over R. This is typically referred to as our velocity formula. So if we either have velocity and radius and we're looking for centripetal acceleration, or vice versa, if we're looking for velocity and we're given the other two, this will be the formula we use. And it's often referred to like the velocity centripetal acceleration formula. Okay. The second formula we have is a little bit longer, but it's not too much more complicated really. We have centripetal acceleration is equal to 4 pi squared times radius over period squared. And we talked about period in the last lesson, last example. Period is the time it takes to make one lap around a circle. Okay, this is often referred to as the period formula or the period centripetal acceleration formula, because vice versa, if you're given AC and radius, or we can find period, or vice versa, we can find AC or R even, given the other two. Where 4 and pi are just absolute values and they're never really going to change. Okay. That said, those are our formulas. That's how we're going to use them. Let us jump into this example problem. So, we have got... that's not red. We have got the centripetal acceleration of an object being 12 meters per second. If the speed is tripled and the radius is doubled, what is the new AC? So this is a formula manipulating question, just picking one of the formulas and changing it up a little bit. We've done these in past lessons before, and I have kind of a system for these, and the system is just finding the ratio difference. So AC, well, I guess I should go through picking this formula with you. It says we have a centripetal acceleration of 12 meters per second, great. Both of our new formulas have AC. If the speed is tripled, velocity, I think we already know our formula. It's going to be this one. And the radius is doubled. What's the new AC? Well, we're manipulating this formula to get a new AC value. So let's put that formula in. AC is equal to V squared over R. And with these types of problems, I like to find our ratio of difference. So I'm going to not put an equal sign, but I'll put like an arrow sign saying, here's a logical leap. What I like to do is replace all of the changing values with ones, because we're going to be manipulating these things. So we'll say that 1 squared over 1 is our V squared over R. And then we're going to replace our 1 values with the tripled or the doubled. We're going to triple and double these ones. So really now this is going to be 3 squared divided by 2, because it's tripling the velocity, doubling the radius. And that works out to 3 squared is 9. 2 is, well, it's just 2. And we get a ratio of 9 over 2. All right. And our first beginning portion of this question, it said the centripetal acceleration of an object is 12 meters per second. So initially, we had 12 meters per second, and we changed it by these values, so we're going to manipulate it by the ratio of 9 divided by 2. And our new AC is going to be 12 times 9 over 2, which is 54 meters per second. That's really all there is to it. It's not an incredibly intuitive method at first, but practice this a couple times. I think actually even watching this video a couple times, hopefully it works itself out for you. If not, come ask questions. That's all.